Hello friends, welcome back to my channel. Today we will learn how to make the Cmax index and how to make the stress index. So we will first start with the stress index, and for the creation of the stress index, we need something known as the lower bound. Lower bound and upper bound, you might have heard the terms before if you have watched my video on Bollinger Bands. So here also we will construct a lower bound and upper bound in kind of a similar fashion, but not in exactly the same way. So here we take a window of 365 days. So this is a very data heavy process. So firstly, we will create our index. We will create our lower and upper bounds on the basis of standard deviation, that is a static one. And after that, we will do a standard deviation that is dynamic. And on the basis of that, we will construct our stress index finally. So let us begin. So, firstly, while constructing the historical return, you need the average of the past 365 days. So, we need to go down by 365 days. Okay. Uh, so, here it is. So, we will begin from here. So, we begin from the 366th day onwards and we take the average of the past 365 days. So, here it is. Okay. So, here we have it. So that is our value, and let us now do it for all the periods, and let us now copy it and paste it as values. Since we are done with this exercise, now we will delete the data of the past 365 days. So yes, yes. So here we have it. Now let us construct the standard deviation of the entire series equals to stdv dot s. This is the standard deviation of sample formula. Make sure you do not do the standard deviation of the population. So yes, here it is. So lower bound is very simply historical return plus 1.5. Sorry, lower bound is minus historical return minus 1.5 into standard deviation. Now you can keep this to be 2 also, and you can keep this to be 1 also, the coefficient here. So you can do historical return minus just standard deviation, or you can do historical return minus 1 into standard deviation, which is the same as before, or you can do historical return minus 1.5 standard deviation, or you can do historical return minus 2 standard deviation. It depends on how wide you want your bands to be. So here it is, and here we will do historical return plus 1.5 standard deviation. Here it is. However, it is more accurate if we work with a standard deviation that is conditional on the date and that is conditional on past data rather than such a static value of the standard deviation. So let us now take our Sensex return series onto eViews. So let me just copy. Yes. So finish. Okay. So now we will just, I have shown this before many a times, so we'll do it again. Estimate return, we will do Sensex return C, and we will do an arch model. This will be EGARCH error distribution. Let's keep it GED. So where it is. Okay. So now we need to find the conditional variance. So we go to prop, we go to Arch variance series, and we write CV. So here we have it. Let us now just copy it. Sorry. Okay. Let's now copy it here. So let me bring my historical return onto this sheet. Okay. And here I write CV. And conditional standard deviation should be CSD. So it is equals to square root SQRT of this. So here it is. Now let us find the lower bound. So lower bound is equals to historical return minus 1.5 into CSD. Here it is. Now my stress index is calculated as equals to, if my actual return, okay, is less than the lower bound, then my stress will be, then there is stress. This is an indicator function. So then I consider that there is stress, and if not, then we do not have stress, which we indicate by 0. So see, here our Sensex return is not lower than minus 0.002, yeah, is not lower than the lower bound, because lower bound is even lower. It is minus 0.004, right? So it yields 0. So here it is. Now we can even plot it. Sorry. Actually, if you plot it for like smaller periods, no, it will be more understandable. See, when the bands are very light, that means we do not have much stress. But in periods when the bands are like very dark, it means they are stress period, like in 2008 and then in 2020. You see that the stress was much higher. So that is how you construct the stress index. Now let us move on to the Cmax process. Okay. So for the Cmax, we need the maximum of the past 365 days. So let us just copy our data set here. Okay. So we need the maximum. So I write max. So now let us go down by 365 days. Yes. Wait, I did not want any formula. Okay. Sorry, sorry. Okay. So here we are. So let us find the maximum of the past 365 days. So the formula is max of the past 365 days. Okay. So here it is. We have the maximum of the past 365 days. So now let us just copy and paste it as values, and let us delete the rest of the data. Now our Cmax index is given by, it is given as return divided by the maximum value. Okay. So let us now plot the two. So in periods when Cmax is very high, it means that it is a good period. That means my RT is higher than the maximum of the past few periods. My return is higher than the maximum of the last 365 days, which is a good indicator. But in periods when Cmax is falling, okay, so that means that there is stress. So if Cmax is falling, that means my present return is much lower than the maximum of the past few days, which is not a good indicator. So I repeat, so Cmax rising means our return rises in proportion to the historical maximum, and Cmax falling means a stress period. So that is how you can use Cmax in your analysis. And so this was the construction of Cmax. In the next video, we will learn how we can use Cmax as a threshold variable, and we can use it to understand if an asset is a diversifier, a hedge, or a safe haven using Cmax. So thank you so much for watching this video. That's all for today. I'll just see if there is some other graph that we can make. Yes. Okay, in the next video, we will show how to make a TAR model with Cmax, how to use Cmax as a threshold variable, and create a model. So thank you so much for watching our video. So we end it here today. Thank you.